Welcome to Algebra 51. Like Area 51, we contain secrets to this mysterious math that we're gonna share those secrets with you today. So buckle up and enjoy this ride on this mysterious. We're gonna do math problems. Yes. We're gonna do math problems. So anyway, sit back and enjoy because today we're going to talk about the properties of addition and multiplication, and it's going to be really fun. It's going to be very helpful, and as long as you keep these foundations at hand, you're going to be fine. So let's talk about, now that I'm saying they're foundations, the properties of this foundations. What's what is the importance of a foundation? Well, nobody can think of a better thing. No one appreciates the importance of a foundation more than the Leaning Tower of Pisa. Because the Leaning Tower of Pisa, if you notice, is leaning. It's leaning. And it has been leaning for 850 years. I don't know how they managed to keep that thing from falling, but I guarantee you, there's a one way to make it fall. Put me on it. It'll fall. But that's my luck. But the point being is, foundation is very important. In 1173, I believe, the Leaning Tower of Pisa was established. And what happened was they didn't check the foundation. Somewhere in the foundation, it tilted. But it didn't fall. It's a miracle that it did not fall. It has nothing to do with engineering, although the fact that it's still standing today tells me that the engineers were pretty good at what they did, and it was pretty solid built. But I'm not getting on it. No way. So anyway, that's what we're going to talk about today. We're going to talk about foundations, why they're so important. If you don't have a good foundation, like the Leaning Tower of Pisa, you're going to have problems. Even though it's been around for 850 years, it ain't going to stay that way. Because that thing is just an accident waiting to happen, a disaster waiting to happen. So, on to our next. These are the properties of addition and multiplication. And we're going to assume, and in this red here, this is what we're going to assume. Now, don't get me about assumptions, but let A, B, and C be real numbers. And see that thing right there? That right there is for all real numbers. If you've ever wondered what that meant, that means all real numbers. This right here means it's saying that these things are real numbers. This right here in blue is the math language. That's how we write it. We write it this way. These symbols, we've all agreed on what they become, and that's how they do it. Now, let's start with the first one. These are properties. These are additional properties, and these are multiplication properties. Because different things happen depending on how you do multiplication or whatever. So you start with the properties of closure. Closure, all it says is if you add in the additional property column, all it says is if you add A and B, they're going to be real numbers. If they're already real numbers to begin with, you add them together, you're going to get a real number, right? Same thing with multiplication. You multiply them, it's going to be a real number. So just remember that's closure. Very easy one to remember. Commutative. It's commuting. Looks like it's commuting from one side to the other, doesn't it? Maybe that's why they call it commutative. What this does is it's saying that A plus B also equals B plus A. Test it out yourself. All you got to do is go look at 2 plus 3. Is 2 plus 3 equal to 3 plus 2? Yeah. 2 plus 3 equals 3 plus 2. Same thing here. A times B equals B times A in the multiplication column. So does 2 times 3 equal 3 times 2? Yeah, they both equal 6. So that works. Here's another one. Associative. These are, they can associate with each other when you're doing the additional properties, and they're real numbers. I gotta say that, stress that. They are real numbers. Now, A plus B in parentheses plus C equals A, and then move the parentheses and regroup with the B and the C. They both work. As long as you do that, as long as you have this kind of setup and they're real numbers, they both work. Same thing works with the multiplication properties of the associative property. A times B in parentheses times C is also equal to A times B times C in parentheses. They just reassociated the B and the C together. That's why you call it the associative properties. And we kind of commute looks like you commute. But anyway, we're gonna try to look at different ways of looking at that. Identity. Identity means, it is what it is, basically. You're identifying this. Now, if you take A and add nothing to it, you add 0 to it, it's going to be A. If you take 0 and add A to it, it's going to be A. Point is, these work both ways, where you're adding 0 to it. Same thing over here with multiplication, except it's a little different because you have to multiply by 1. You multiply by A times 1, you're going to get A. And because of the commutative property, if you multiply 1 times A, it works. See? Same thing here. Commutative property is actually being used in the identity property. You look right here, A plus B, A plus, and B equals 0 in this case, and equals B plus A. B equals 0, A, boom, boom. Did it, right? Now, next, you now have the inverse properties. The additive inverse of a positive number is a negative number. The additive inverse of a negative number is a positive number. So, but the point is, you have to understand the inverse on the additional property is just subtracting this, and they always equal 0. And over here, it's a little different because you're actually multiplying the inverse. This is actually the inverse. It can also be written as A to the negative 1, which is what an inverse is usually written as. And so A times 1 over A equals 1. This is the inverse. If you multiply the inverse of A, it's going to get 1. That is as long as A does not equal 0. Because if it equals 0, it goes to infinity and beyond. But that's calculus. We won't worry about that right now. Next, you've got the distributive property. Now, you may be asking yourself, how come I don't have an additive property for this and a multiplicative property for this? And the fact is, this last one, they're using all these together. Look at this. A times B plus C. They're multiplying and adding in here. So there's a mixture of the two. So they're working in conjunction together. So that's why distribute is always easy. Seems like every time I talk about distributive, kids get this one. This one's a little bit easier. You're distributing it both. That's what you're doing. You're distributing this to this and this to that. A will be distributed to B. A will be distributed to C, and you will get A times B plus A times C. And those are your properties. If you can, these properties are very important to remember, and if you can remember these properties, all of these properties here, you'll find that they're very helpful for you, and you will be able to do your math problems a lot better. But you got to memorize these 6 things. 1, 2, 3, 4, 5, 6. Do you remember these 6 things? You will be great. Now, my recommendation, I'm going to stand right here, and you feel free, take a snapshot of this if you know how to do that on your phone, or take a picture of it with your phone. But the important thing is, take a picture of this, but do not just take a picture of it. You are not a computer. You're not that dumb. You're smart. So you have, but, and you say, well, the computer figured it out. No, the computer didn't figure it out. You just took a picture of it, and your computer has a picture of it. But it doesn't know these properties unless we teach these properties. And it's just like you, and the same for you. You don't know these properties just because you took a picture of it. So don't just take a picture of it. I would spend time writing these down. Do it a couple of times. Chill out, while you're watching, listen to music or whatever. Write these down. Get them in your brain. You have got to process this into your brain. So go ahead. First, matter of fact, what I would suggest, another good way, is just freeze this on your computer screen, pull out a piece of paper and just write them down. And just write down closure and say them out loud in your head, because you need to process it in your brain. And if you talk it out and tell yourself that. And as a matter of fact, another thing you might want to try is, once you get these written down, go and try to set them down after you study them a while, set them down and explain these things to your parents. They would love to see you be smart. They would love that. All right, so your parents would love to see you do something where especially if you're doing homework, they love that. But anyway, those are your properties of addition and multiplication. We're assuming they're all real. And this is what, if you learn these, you'll do great. All right? And that's all I've got to say. So, and another thing, remember that any type of, and this is a tutorial program. This is a tutorial site. And we don't charge, we work out some deals, but any donations that you can make would be most appreciated. And if you have any questions, just go to George at algebra51.com.